Hello. Today I'll be speaking about ZODB, the graph database for Python developers. There's been a large interest in graph databases recently. Here are the 5 largest graph database vendors. Let's take a closer look. OrientDB, ArangoDB, MarkLogic, they're all done, and Neo4j, they're all done in Java. MarkLogic received $173 million. Neo4j, $80 million in venture capital, huge amounts of money. But these are all done in Java. They're not as flexible as Python. Typically, they have one or a few data types that they support. So Neo4j just does what's called a graph, property graph. Some of them do document, key value, object stores, RDF, XML, JSON. They each do one or a few data types. Whereas in ZODB supports persistent Python, basically any kind of data structure that you can represent in Python, the ZODB will support. I think there are even 2 different groups that have done relational database interfaces on top of the ZODB. How much venture capital did the ZODB get? Well, they got something much better than venture capital. They have users, they have lots of users, and the ZODB has had lots of users for a long period of time. Just the government of Brazil alone has 100 different websites all running on the ZODB. This is like the president's office, the parliament, various government offices. And that's just Brazil. In Europe, it's quite strong also, where people need multilingual websites. So lots of users have been using it for a long time. Very, very solid database, reliable, just really, really rock solid. So why would you want to use a graph database? Well, the big one is, of course, social networking. It's just obvious to represent it as a graph. And of course, computer networking. Those are 2 of the very obvious applications for graph databases. And of course, the Panama Papers, that was all done on a graph database. The user said it was just so much more intuitive than trying to do it on a relational database. And a lot of fraud detection. 6 of the 10 largest companies use 6 of the 10 largest banks use graph databases. And I think it's going to be really big in natural language processing. So on the left here, we have a tree, NLTK parse tree for a sentence. But as soon as you have a paragraph, you've got multiple sentences, and those parse trees, they intertwine, and they create graphs. And so on the right-hand side, we have the ZODB Graphicus example. We'll come back to that later. So it's really easy to use. Here we have a TreeLeaf class. It's got an initialize method and a render method. And to make it work with the ZODB, we just, instead of subclassing off of object, we subclass off of persistent. So that's the persistent object class. There's a persistent dictionary, persistent node graph container, which contains multiple items. So this is also a persistent container class. So how do we use it? So we can create a leaf equals TreeLeaf with a name, and root.leaf equals leaf. And in reality, you don't just create single objects, you create large numbers of objects, like large numbers of account objects or people objects. And so on the right-hand side, we'll see leaf1 equals TreeLeaf called a green leaf, leaf2 is TreeLeaf called it a red leaf, and then underneath that to the root, we add, under name leaf1, we add leaf1, and under name leaf2, we add leaf2. So very easy to create objects, create trees of objects. Of course, you have to create a database, so we have to import the ZODB. There are multiple different ways of storing the data. We'll come to that later. But say we take the basic one of ZODB file storage. We create a database using the command. We call it data.fs. We get a connection to it. We get the root objects. We do some stuff to it, and then later we do a transaction.commit. So really quite simple. Generally, the frameworks do this for you, so I almost never even see this code. And of course, it's just Python. Say we want to update a leaf, we get the root object using the techniques I just showed you. We asked it for leaf1, we set the title to be yellow leaf and do a transaction.commit. Below that, we can do a stupid query over the root object for key item in root, print key and title. Sorry, that should be item.title, my apologies. On the right-hand side, if we want to delete an object, just do delete root, delete the object called leaf1 in root. Again, transaction.commit. So it's really just Python. There's no SQL select here. You're using Python functions to navigate the tree and operate on it. And so it's really magical. It gives you the illusion that your Python objects are persistent. You reach into the database, you pull out a root object, you do some things to it, you attach it, you commit the transaction. You want to delete those objects, you remove them from the root object, you commit your transaction, they get garbage collected. Really simple, really easy, very fast, very nice. Is it a graph database? Well, let's go back to our leaf example. Say we have two leaves, and on the lower left, we attach them both to the root. On the right-hand side, we're going to turn it into a graph. So we're going to have leaf1.sibling equals leaf2, and leaf2.sibling equals leaf1, do the transaction or commit. So suddenly we have a root. We've got two leaves, and each of those leaves point to each other. We could do it even with more complex graphs. It works. It all just works. From the developer, it just gives you a really nice interface. You have to commit the transaction. And how are objects persistent? Well, if you can reach an object from the root, it's persistent. So remember our leaf1, that you could either access it from the root by using the dictionary functions, or you can access it by the sibling. So if we go to root and we delete the leaf1 from root, it's still around because we can access it through leaf2.sibling. But if we go and then go delete leaf2 from the root, then both of those objects are going to get garbage collected because they're just not accessible from the root. It is a proper ACID database. I won't go too much into this. I'll just say that it's an optimistic concurrency control database, and more importantly, it has a feature called history. So it keeps around historic versions, and this is wonderful if you're doing any content management, or if you're doing HTML or CSS or JavaScript development through the web, where you want to keep previous versions and be able to refer to them. Here's the interface from Plone. This is the most gorgeous interface. All of these tools have something similar. It makes certain types of development much easier. Certainly much easier than trying to use Git for the beginners. Okay, so what are the advantages? Comparing it to sort of a traditional relational database, Django application. There's no database schema, there's no object relational mapping, there's no referential integrity problem, you get automatic garbage collection, and no reads and writes. Huge, huge advantages. How do we store the data? Well, there are multiple ways of storing the ZODB. If you just use file storage on a single process, it'll store most of the data in a file. Actually, now it stores it in multiple files. And it'll store the blobs in separate files called blobs. You can imagine, you can also put those blobs, say, on Amazon S3 servers. When you start to get to the client server version, you get ZO. And so some of the data is stored on the server, and it's cached on the client, and so the ZO server also uses file and blob storage. You can also do rel storage, where you store the objects in either Oracle or MySQL or PostgreSQL. And if you're using PostgreSQL, you may want to go with NewtDB, which actually keeps two copies of the objects, one in the database, but also it uses the PostgreSQL indexing function, so that's really fast. So lots of different options for how to store it. I guess there's actually a memory storage, there may be some other options too. How do you access an object? Well, here we have a tree of objects. So often people start off with trees before they do graphs. So we're trying to get to the object on the lower right-hand corner. Slash takes us to the root object. Slash software takes us one level down to the right. Slash software slash libraries, 2 levels down to the right. Slash software slash libraries slash database libraries takes us all the way to the object on the lower right-hand corner. So this is accessing objects by traversal. What I've also done is canonical access. So if you have a website where the nodes move around a lot and you want them to have a canonical URL, what we do is we give each node in the tree its own unique name. And so you can then access the objects two ways. You can either access them traversal, or just in the root there's another index which indexes them directly with their own name. And of course this turns it from just a hierarchical database into a graph database. It just works really easy. Didn't even realize I was now using a graph database. So that's how we access the objects. The way we display them is we have views on objects. So in a Unix file system, you're going to have files and you're going to have applications. And there's sort of, some files may work on some applications, there's no real connection. When you're working on the ZODB, you have views on objects, and there's a whole registry that records which views are visible on which objects. So basically you could just query, say, for this object, which views can I use? And the basic views you want to use are the CRUD views. So like a relational database, you have create, read, update, and delete. But again, it's not a relational database, it's a graph database. So you have what's called ZODB extended CRUD. Because you traverse in with a URL, you may want to rename a URL segment. That's called renaming an object. You may want to cut and paste either an object or a whole branch of the tree. You may want to copy and paste either an object or a whole branch of the tree. And you may want to visit the history, see what all the different historic versions are, and restore one of them. So that's called extended CRUD. So let's first take a look at this create, read, update. What you need to do that is you need some meta information about the classes. So on the left-hand side, we have a TreeLeaf object. At the top, the first line is called at implementer of iTreeLeaf. So that's where you define the meta information, the abstract interface information. On the right-hand side, you're going to have this iTreeLeaf object. And basically, it defines two attributes. It defines title and body. And let's look at the lower one, body. Basically, we're saying it's a text area, it has a title, and it's required. This ZODB.schema gives you a rich suite of types that you can do here with options. And in reality, you're going to have multiple views on multiple nodes on the tree, and not all views are going to apply to all nodes. So, example, a leaf, you're not going to be allowed to add stuff to the leaf. Or the root, you're not going to want to delete or rename it or cut it and paste it somewhere else. In a complex application, you'll want to add account objects to certain branches, and you want to add people objects to other branches, and maybe you want to add company objects to other branches. So any real rich application has a rich collection of which views apply to which nodes, and there's a way for configuring all of that. So we're going to go back to our TreeLeaf object, and on the right we're going to do a very simple iTreeLeaf. And this one we say it inherits from iDisplayable and iEditable. And so what we basically said is because it supports those two interfaces, the views, the display view and the edit view, will work on this object. And in fact, we have a rich list of CRUD. On the left-hand side, we have a list of CRUD, and on the right-hand side, we have the interfaces that will support that CRUD. So many of the objects, the CRUD operates on them, but when you're adding something, for example, when you're creating something, you really do it to the parent. The object doesn't even exist, so the interface doesn't matter. You're doing it to the parent. So there'll be like a container that says you can add a leaf, you can add a branch, maybe you can add an account object, and that container has the interface I add leaf, I add branch. So it's very well defined. You can add this kind of content to this type of object, to this type of container. Very, very easy. And of course, in practice, we publish an iLeaf or an iContainer or an iRoot container that has all of these for you for the default cases. Makes it much easier. So that's the model of the objects, but you also have to look at the distributed object and how do you scale this up. So typically on a website you'll have multiple clients and they'll all connect to through a load balancer to one of the serving processes, and those will then connect to the ZO server where the data is actually stored. So you store the data on the ZO server, but you need a cache of those in those ZO clients. And when a transaction happens, a read transaction is not a problem, but a write transaction, you're going to update some objects, you're going to invalidate those caches, and you're going to update on them on the server, invalidate the caches, and if somebody needs to access those objects again, they'll have to reload them from the server. Speed. ZODB writes transactions to the end of files. It now supports multiple files, so it happily does thousands of write transactions per second. As read transactions, it'll scale up as much as you want. In terms of scalability, database size, very happy with hundreds of gigabytes of memory in the main memory databases, in the file databases. And then for blob storage, maybe on S3, it goes up to terabytes. If you need more data than that, there's a cousin to ZODB called Neo, not Neo4j, this is Neo. And the Neo database in production goes to 80 terabytes. It runs on multiple computers. And in test, it goes up to 160 terabytes. A lot of data. For security, security is all done very intelligently. The interesting thing is ZODB. These guys did a small fork of the ZODB, and what they did is the server knows nothing. So they do all the encryption and decryption on the client, the JavaScript clients. They do all the encryption and decryption on the client, and so even if you host in the server in the cloud, the people who run the cloud have no idea what's in your data. Just brilliant. Even the indexes are decrypted on the client. So real brilliant piece of work. You can find the GNU, the GPL version, you can find it on GitHub. Actually, they also do a relational interface to the ZODB, so that's kind of interesting. The next question people ask is, how does a ZODB compare to relational databases? Well, ZODB, you start off with a tree, you can do a graph. Relational databases, hopefully you all understand pretty well by now. There are some things that are really easy to do in the ZODB and very hard to do in the relational database. So say I have a node. In my case, I have 10 different classes. That would be 10 different tables. I'm never quite sure which classes in a particular node. So if I were to search for all the items in a particular node, I'd have to index across 10 different tables. I'd have to search across 10 different tables. Actually, I have some hints as to which might be which. So on different nodes, I'd be querying different tables. It would just be a nightmare. In ZODB, what I do is I just iterate over the node. Maybe say I print the representation for each object. I just iterate over the node, and if it needs to, it reads all those objects in and gives me the results. Way, way easier. Okay, so there's always a balance. In relational databases, it's really easy to do a sort of query and a select statement on some values. And the ZODB, if you're going to do it that, as opposed to using Python methods to access things, then you have to create your own catalogs. And so it's not that hard to do, but it's additional work. I have a slide on it if you're really interested. Coming back to applications, here's the Graphicus, a very nice piece of work, kind of demonstration of a concept. On the right-hand side, representing the same thing as sentences. You can as a paragraph of sentences. You can easily imagine reading these sentences in and creating the graph on the left-hand side. I think that natural language tool processing is going to be a huge area for the ZODB. I'll show you the ZODB demo I built. So the idea is that if you want to start using the ZODB, there's a whole bunch of stuff that you can get sort of for free. So the CRUD, so across the top we can see add a tree branch, add a TreeLeaf. Those are sort of templates just to show you how to do things. You can delete an object, display it, edit, manage it, view, log out. So the difference between display and a view is that display will show you based on the ZOP.interface, based on the interface definition of the parameters, whereas view will use a template to display how you view it. So multiple ways of accessing it. And then below that, you can think of this kind of like a node on a file system, a directory in a file system, but again, it's a graph of objects with views on those objects. And here we can choose which of these objects we're interested in, and we can rename it, we can cut, copy. If we do that, then a button appears for paste, we can delete them. So basic extended CRUD operations are supported by the ZODB demo. The ZODB demo is targeted at people who want to do file system development. So you've got some people who are very comfortable with Unix and a shell and Git, and they want to do file system development. The ZODB demo makes it really easy for them to get started. There are other people who'd like to use a graph database, but they don't really know all that stuff, and they want to use it through a browser and bring up a website quick and easily, and Git is too complex, and they want simple history and restore. So I haven't yet released it, but I'm getting close to releasing Apache as an integrated development environment. So you can add, here you can see the add menu, you can add HTML, WYSIWYG objects, and more technical ACE editor, HTML objects. So that's a syntax checking editor. You can do CSS, again with syntax checking. You can add containers, you can add JavaScript scrollers, even Python functions, all again with syntax checking. So if you go to my website, you can see these demos. I don't want to spend much time on it, but I do want to show you one particular piece, the history piece. It's kind of interesting and very powerful. And so here we have a demo of this Apache integrated development environment, and you can see the different content types. So let's take a look at the view. I recently had someone write some marketing literature for me. Let's see what he came up with. So Apache, the world's only graph-based, user-friendly web development platform. That's okay, but it's kind of sparse. So let's see what we can do. Let's go back to the historic versions. Let's see. History. Okay, here you have the different versions. We can look at them. Version 1, this 1.0 is the one that we just looked at. I think this is the original one that I did, restore. Yeah, that's the original one that I did. And so, back up, there we go. So let's go ahead and restore it. You can see there's a new version now. And now when we view it, okay, I like my version better. And of course, if we wanted to, we could have managed. We could have used the graphical editor. Here's the CK editor. We could have used the graphical editor to merge his changes in with it. Okay, that's the end of the demo. I just wanted to show you that history. It's a really powerful piece for people who are doing content development. So now we're going back to, okay, next slide. And so the magic of this Apache integrated development environment is what I call web classes. Imagine this is a tree of Python objects, ZODB Python objects. You can imagine that several of them will all have the same Python class. We have the blue objects. The green are the Python class information, a tree of Python classes. This everyone here understands. But the problem with a Python class is you really have to be a web developer. You have to be a Python developer to add something to it. So what I've done is I've created something called web classes, where each of these ZODB objects can optionally have a web class. And so the user can just add to that image or an HTML fragment or a CSS fragment or some JavaScript. And all of those Python ZODB objects can then acquire that content. Very, very powerful in what I'm doing. I don't quite know how to present this to people. So the best thing is I'll be very shortly releasing the Apache integrated development environment, and people can play with it and they'll see it, experience it, and understand it. So that concludes my talk. There's time for questions. If you are watching this online, then I invite you to contact me, Christopher Lozinski, at pythonlinks.info, or you can send me an email, you can contact me on Skype, you can call me, whatever works for you. Thank you so much for your time.